Okay, it's 7:02. I think we're going to go ahead and get started. I have an announcement I'd like to make before I give the floor over to Meera. But thank you everyone for tuning in tonight. My name's Kayla Del Biondo. I'm the Digital Services Librarian at New Canaan Library, and I'm super pumped for tonight's program. Before we get started, I wanted to announce to everyone a really exciting initiative that New Canaan Library is a part of. We are an official partner of the 6th annual Greenwich International Film Festival, which will be streaming virtually for the first time in history, obviously because of the circumstances. It's about 3 to 4 weeks out from now, May 1st through May 3rd, 2020. What you can do if you're interested is I encourage everyone after this lecture to go to our main library homepage, newcanaanlibrary.org. Right in that homepage slider at the top, we're featuring our partnership with Greenwich International Film Festival. And it's super important if you do want to buy a virtual pass and view it like on your own or with your family that May 1st weekend, we please ask that you buy tickets through our website, because 20% of the tickets that are purchased through our website, that money is going to come back to us so that we can continue delivering excellent programs and curating our physical collections once the library is back open. So there's that. So everyone check it out on our website afterwards. And now for tonight's program, I just wanted to introduce Meera Zassenhaus. She is the Community Engagement Associate at New Harvest. New Harvest is a nonprofit research institution based in New York City that strategically funds and conducts open, public, collaborative research that reinvents the way we think about animal products without animals. So Meera, I'll let you go ahead and get started. Thank you for being here.
Thank you. Hello, everybody. I'm very excited to be here and talk about this kind of crazy science fiction sounding idea of growing food, especially meat, from cells. So you might have heard of it as lab-grown meat, but that only scratches the surface of this larger field called cellular agriculture, which is the growing of animal products without animals. So let me go to the next slide. Okay, to set the stage, I want to start with something that I think we can all get behind, which is that animal products are amazing. The meltiness of cheese and the ability of muscle fibers to hold together fat and water and things like sausages. These are qualities that many have tried to reproduce with nuts and soy and pea protein, and in recent years have come really close. I don't know if you've had an Impossible Burger, but something's always just a little bit off. And that's because animal products have functionalities that you can approximate, but simply can't reproduce with animal proteins. Unfortunately, the production of animal products, by which I mean the industrialized farming of animals, is a disaster. For one, it's bad for the environment. Less than a year ago, the Amazon, the world's largest source of biodiversity, was on fire. And the reason for that was because swaths of it were being raised for beef, making the whole climate dry and basically kindling for the fires that ensued. More than 70% of agricultural land is used for livestock, either to raise the animals themselves or to grow food to fatten them up before slaughter. And Brazil is one of the world's largest exporters of beef, which is one of the largest species of livestock. And as you can see in this picture here, that most of the fires that happened in the Amazon were in zones where cattle were being reared for slaughterhouses. Which leads me to my next point, which is industrial agriculture is extremely vulnerable to disease. It makes us as humans vulnerable too. I was originally supposed to come here and talk to you in person, but then we were struck by a global pandemic. Coronavirus, a zoonotic pathogen, meaning one that can jump from an animal to human. Coronavirus likely came from a bat and maybe a wet market, but the reason it got from a bat to a wet market and from that wet market to us here in Connecticut is because of industrial agriculture. That same deforestation I just talked about in Brazil, well, that happens in Southeast Asia too. And that deforestation brings deadly viruses that have already always existed deep in the wild, much closer to humans than Mother Nature intended. And so it removes that buffer zone that shields us from exotic pathogens like the one coronavirus in the bat. And that's just one of many diseases caused by agribusiness. Earlier this year, pig Ebola wiped out half of China's pigs, which is the largest swine herd in the world. And before that, we had to cull 50 million chickens in the Midwest because of avian influenza. So factory farmed animals' close quarters and lack of genetic diversity gives us consistency at the grocery store, but it makes animals stupidly vulnerable to disease. So if one animal contracts the virus, they all have to be killed to contain it. Industrial livestock production, as it exists today, is basically a cesspool of pathogens, any one of which could cause another pandemic. And these pathogens, including antibiotic resistant bacteria, can spread from animals to humans via food, via animal to human transfer on farms, and through contaminated waste entering the environment. And even when there's a thing like a spinach recall, that's normally because of contamination from animal manure. And finally, there's the kind of self-evident fact that animal products come from animals. So I'll spare you the details of animal cruelty, but I think we all know by now that the industrialized farming of animals isn't the rosy picture we see on packages. We're treating animals like meat-making machines and exploiting their bodies to get the maximum meat for the cheapest price. So this picture is a chicken from 1957, and then a chicken from 2005. And there wasn't some huge technological intervention. This was just from breeding one fat chicken with another over and over again. And I bring that up because animal agriculture has been optimized. Centuries of agricultural technology has made what happens today about as efficient as it can be, considering the fundamental inefficiency that we're growing a whole animal to harvest the bits and pieces that we need. We need more transformative change. The way that we make animal products is simply unsustainable for the world to maintain doing at the scale we're doing today. And I'm proposing that cellular agriculture be that transformative change. So, what is cellular agriculture? It's the growing of animal products from cell cultures rather than animals. If we're already treating animals like machines, like living bioreactors, cellular agriculture asks, what if we took the animal out of the equation and reproduced what happens inside of the body, outside of it, in an actual bioreactor? So start with a cell and grow what we need, rather than growing a whole animal just to pick apart the bits and pieces that we want to eat. I believe this future is possible. And the reason I believe that is because these are 3 prototypes of animal products already grown without farming animals. So up top is a meringue from a company called Clara Foods, which grew the main protein found in egg whites of albumin without hens. And then to the right is casein, one of the 2 main proteins in milk, which was grown without cows from a company called Perfect Day. And then to the bottom is a burger. So the first cultured burger debuted in the Netherlands in 2013 by a researcher named Mark Post. And it cost $300,000, which certainly isn't more efficient than a McDonald's patty, but that's because it was just a proof of concept. And in the world of biotech, that's not even that expensive a proof of concept. A couple years later, a company named Memphis Meats, which is based in San Francisco, made a cultured meatball, which at $18,000 per pound was a little less expensive. And then just this past year, a company named Shiok Meats in Singapore made cultured shrimp dumplings. So this was $5,000 for 1 kilogram or 8 dumplings. And these are just 3 examples of several prototypes. My point being that cultured meat isn't impossible to make, but it is difficult. Many predictions have been made for when cultured meat would come to market, all of which are kind of listed on this screen today, including one by Winston Churchill back in 1931. But all of those dates have since come and gone, and that's because it's really quite the technical feat to make so texturally sophisticated a product like meat, from cells. That being said, the basic idea is as follows. There are 4 building blocks to cultured meat: cells, scaffolds, media, and bioreactors. So to start, you take cells from a species of interest, in this case a cow, and in order for those cells to multiply, they need kind of food to eat and grow. That food is called growth media. And in order for them to multiply into a structured shape, they need a surface on which they can grow. So that's your scaffold. And then in order for all of this to go as planned, they need some kind of controlled environment, which provides the right conditions, like heat, for the cells to grow. And that's the bioreactor. So it's an elegant idea, but pretty hard to do. And there's a long way to go before we perfect each step of this process for large-scale production. But cellular agriculture is more than just meat. And what's a lot easier to do is grow acellular products, like what I mentioned earlier, milk and egg proteins, which don't require growing a bunch of cells into some sophisticated shape. And the way this works is you take a gene of the protein you want, like casein, and put it in yeast, which brews and churns out the protein of interest. And unlike meat, where you need to go collect cells from kind of a host organism, DNA synthesis has become so routine that the donor organism is typically not needed. So you can just look up the gene for casein or whatever animal protein you're interested in some kind of sequence database. And it's not actually particularly new technology. So the first cell ag product is largely regarded as insulin. So you used to have to farm a bunch of pigs and then extract porcine insulin from the pancreatic glands of thousands of pigs, which was extremely expensive. And so in 1982, they figured out how to engineer an easy to grow microbe. Now they use E. coli to produce the human form. And this eliminated the risk of viral contamination with the purification process and significantly reduced the cost to make it, as well as increased supply. And then another cell ag product you're probably already familiar with is rennet, which is used to cleave the milk protein casein at a specific site, causing it to curdle and create cheese. So the primary active component of rennet is a protein called chymosin B, and that's normally found in the lining of calf stomachs. So historically, the stomachs of slaughtered unweaned calves were scraped out to obtain these milk curdling enzymes in the form of rennet paste, which was then used to curdle milk in an early step of cheese production. But in 1990, the FDA approved the first fermentation-produced chymosin. And so these are 2 kind of classic, everyday examples of cell ag that we already produce at an industrial scale via fermentation. So what cell ag is proposing is that we do this with many animal proteins rather than just a few. But I want to go back a little bit and talk about how the first cell ag product is widely regarded as insulin. So by genetically modifying E. coli to produce the human form rather than harvesting it from pigs, it was theoretically supposed to make it a lot more affordable. But the 27 billion insulin market in the US is dominated by these 3 major companies. And because of their patents and the constant tweaking of those formulas to renew the patents before generics can ever enter the market, insulin never got cheaper. It got cheaper for them to make, but in fact, the technology enabled them to make it more expensive to sell to the public. And so that's why you see stories after stories of people in the United States going bankrupt because they can't afford their insulin, or going to Mexico or Canada where it's cheaper. In the last 60 years, it's gone from 75 cents to $250 per vial, which is an increase of nearly 43 times the rate of US Consumer Price Index inflation. And so a project called the Open Insulin Project is trying to reverse engineer what these companies are doing into these kind of DIY insulin kits that people like you and me can grow ourselves at home, trying to kind of democratize these means of production. And so the story of insulin is a cautionary tale for cell ag because we like to talk about the radical potential of this biotechnology, which is true, but good intentions can be sabotaged by IP and corporate interests. And so a kind of cautionary tale from Insulin is the consolidation and monopolies and predatory behaviors shared by both big pharma and agribusiness. And that is where New Harvest comes in. So I work at a nonprofit called New Harvest, and we are the nonprofit nucleus of this constellation of startups and researchers all racing to commercialize cultured meat. And what's interesting about New Harvest is that we're a nonprofit funded by foundations and people like you. And we don't invest in companies. Instead, we fund academic research. And the reason for that is because if cellular agriculture is to become a proper industry, which I really hope happens, then there needs to be a pipeline of talent and expertise coming from academia, just like there is in meat science, which kind of props up agribusiness today. And there isn't actually an apparatus for that pipeline right now because Cell Ag sits at this kind of difficult intersection between food and medical science, where grants in both fields are siloed to food or medical applications, but not interdisciplinary applications between the two. So what we do is give students and researchers the additional money they need to pursue agricultural applications of what is a traditionally medical technology, that is tissue engineering. So the traditional model for biotech, and our frame of reference is pharma, is that a lot of money is invested in agencies like the NSF for early stage discovery research. And then there's kind of this valley of death for that period when the research leaves the lab because it's promising, but it's not quite ready to scale. And once, or if it gets that money, it turns into products that change the world. But with Cell Ag, because of that kind of sitting at the difficult intersection I talked about a second ago, we're seeing lots of interest in startups, but there's that gap in that very important discovery stage research. And what has resulted is that there are all of these different startups all working on overcoming the same hurdles, but since they're funded by private money and their research is protected behind IP because of that funding structure, they're unable to share their progress with one another, because this is really pre-competitive research. And so New Harvest's idea is that if we find out this research in a setting that's open, like academia, then it can be openly published, then everyone has access to these same basic tools. And then they can iterate and innovate upon them privately, but the building blocks are open and available to everyone. And we believe that's the best way to accelerate breakthroughs in Cell Ag. So here are some of the researchers we fund. Santiago is at the University of Ottawa, and he's researching how to grow meat cells on decellularized plants like celery and artichoke, mushroom, jackfruit. So meat cells, like I said earlier, as they multiply, they need something on which they can adhere. That's the scaffold. And so Santiago is exploring different vegetable scaffolds, which can produce the full three-dimensional experience of eating meat. So up top is, well, in this case, it's human stem cells used on a decellularized apple carved into the shape of an ear. And then in the bottom is decellularized spinach. And so you can see this kind of empty vasculature. And the idea is to grow meat cells in that vasculature. Another researcher we fund is Natalie at Tufts University, and her whole thing is kind of caterpillar steaks. So Natalie is using insect cells, which are way more resilient and easy to culture than mammalian cells, which are notoriously finicky. So it's insect meat, but actually growing those insect cells, still not farming insects. And then Andrew, also at Tufts University, is researching how to nutritionally engineer meat. So he's looking at how to add vitamin A to meat right now, which would be a proof of concept for tailoring the nutritional profile in meat with nutrients and bioactive compounds not traditionally found, like B12. And so these are just 3 examples of the various research we fund, but I like these projects because they illustrate how Cell Ag isn't just addressing environmental and public health problems of status quo agricultural production, but instead has entirely new culinary possibilities. It's not just about reproducing the foods that are at the grocery store today, but making entirely new foods that were only made possible by this technology. You can kind of think of how there used to just be this milky white substance that was milk. They figured out how to ferment it, fermentation being the first kind of biotechnology, and now we have the whole dairy aisle. There's sour cream and yogurt and a million kinds of cheeses that are stinky and different colored. And so all of these new foods were made possible by this biotechnology. And so the same idea, theoretically, could happen with meat. And so what I want to encourage you to do is think about how this technology can innovate the way we produce food and not just that food itself. So if we no longer need these giant plots of land and are growing meat in bioreactors, akin to giant fermentation tanks and breweries, like how can that change the landscape and fabric of the built environment? Like here in the US, we have this entire rust belt of cities like St. Louis and Baltimore, which were once the industrial centers of this country, but now they're just kind of graveyards with existing infrastructure that's vacant for this new kind of factory. And this, Cell Ag, is just the latest in a long lineage of agricultural technology. And so what would be most disappointing to me is if we squandered this opportunity to remake our agricultural system in a more just and equitable way. Like, this is an opportunity to start fresh, free from the tangled politics and financial interests of agribusiness today. And so we can change not just the modes, but the relations of production. And so there's so much radical potential of cell ag and lab-grown meat specifically, and I'm really excited for what the future holds. And that is it from me.
Awesome, thank you. So let me get back. I'm gonna put my video back on. I'm gonna pull up our questions. Do you wanna stop your screen share so we'll just be side by side?
Yeah, sure.
Great. 1 second. Can you go ahead and make me the host like we did yesterday?
Me make you the host.
Yeah, because I gave it to you just now so you could drive. If you hover over my name, are you able to? Perfect, thank you. All right, now we're both here. All right, so I just want to encourage everyone. Meera is happy to take questions. So right now we're going to do a little bit of a Q&A between she and I. I have 3 or 4 questions for her, but I encourage everyone, there is a Q&A feature in Zoom. So if you have a question that we're not raising and going over, feel free to type it in, and we're going to go till around 8 o'clock and answer your questions. So the first question I have for you, Meera, gets at like some of the common misconceptions around cell ag. So I want to know, like in your professional opinion, what are some common misconceptions about cellular agriculture, and how does this process compare to some other food science discoveries that some people, attendees, might be more familiar with tonight, like cloning and genetically modified foods?
Yeah, so the biggest misconception is there's kind of this large generic category called fake meat, and all of this kind of gets lumped into it. So normally when I describe what I do, people kind of interrupt and ask if I'm talking about the Impossible Burger, which is a pretty unique case in that Pat Brown, the founder of Impossible Foods, is pretty adamant that his technology not be like affiliated with lab-grown meat because he personally thinks it's a stupid idea because it's kind of a moonshot. But Impossible Foods burgers, like the claim to fame is that it's the burger that bleeds. And so while it's a plant-based burger, that technology that gives it its claim to fame is a cell ag process because they culture that heme molecule to give it that bloody kind of taste and look.
Great. So it looks like you just answered Ken's question. He wanted to know how the Beyond Burger was produced. Jacqueline said, is the original source of animal cell grown on the plant-based. So can you just reiterate once more the difference between, I guess, the Beyond Meat products and sort of the demonstration you just went through?
Yeah, so Impossible Foods is, the Impossible Burger has the cultures that heme molecule, and then the Beyond Meat Burger is just kind of exploiting plant proteins to make a patty. But what the Impossible Burger demonstrates especially is that, like, the first products will likely be hybrid products. And so you could have a plant-based patty that's supplemented by culturing kind of meat cells to give it a more robust and like dimensional flavor.
Okay, awesome, thanks. So you went over this a little bit, but I think you were going to discuss it in a little bit more detail. What do you think the timeline or trajectory of lab-grown meat will be should it take off? So, you know, by what year will this be more normalized, and will those prices that you said keep continuing to come down?
Yeah, so that kind of all depends on federal funding. Any sort of transformative technology that seeks to transform the food system the way that this technology does has been backed by government funding. The United States is especially reluctant to fund this. You find that countries like Singapore or like New Zealand are more likely to invest in this technology, and the timeline is, like, we know how to do it. It's just a matter of figuring out how to do it at scale and perfecting those scaling processes, which is no trivial like feat, but it just needs a lot of money.
Right. It's the biggest hurdle. Maybe I'll throw in some audience questions as you and I are going through our questions, if that's okay with you.
Yeah, sure.
Someone asked, is the Beyond Burger and those meat substitutes safe to eat? Can you speak to that?
Yeah, they're totally safe to eat. They're definitely more safe to eat than the meat you get at the grocery store because they're produced in sanitary facilities and they aren't exposed to all those types of pathogens I talked about earlier. And they go through the same like food regulatory and compliance process. So
awesome.
Very safe.
So someone else said, do you think this process will be heavily lobbied against, such as the oil, gas industry with renewable energy? Have you seen this already? That pushback? That
is a really good question and an evolving answer, because yes, at first, companies like Tyson and Cargill were pretty, well, first they were skeptical, then as it became more and more viable, they were pretty hostile. But at the end of the day, they are trying to make as much money as possible. So now they are investing in this technology, which means that they see it as viable, but they don't want to lose out to it. And you see them calling themselves protein companies, not meat companies. And the federal government, like the FDA and USDA, have been working together to come up with a regulatory pathway for this. But you see at the state level, a lot of state legislation passed to try and obstruct the progression of this technology, largely in terms of nomenclature and not allowing them to call it meat. So there's this like tension between federal and state government.
Let's see what the next question was. Let's get back to our questions for 1 minute and then we'll go back to the audience. My next question for you was, in addition to food production, what are some other industries lab-grown meat can infiltrate? You and I, you know, in private, leading up to this presentation, discussed leather and clothing. And how does that production process differ from the food?
Yeah, so all types of industries. Biomaterials are a big one: leather, cotton, spider silk. There's also things like a company called Geltor, which is making collagen for skincare products. They were also making kind of gelatin for gummy bears. An enzyme we use in laundry detergent is technically a cell ag product. So there are all of these different applications, but you have to consider, like, those don't have to be like edible. And so they go through a very different regulatory pathway. They're also produced, it depends on like price point and scale, but biomaterials and the like enzyme industry are two big ones.
What would I'm just going off script now, what would the carrier be in the case of the leather? What would that be growing on?
The scaffold,
Yeah.
my like mushroom scaffolds are really big right now, for both meat and leather. So we're seeing kind of hybrid like leathers made out of mushrooms and also culturing some cells. So that's a very promising scaffold, and also silk.
Wow, super cool. So our next audience question, I don't know if this is a question or a statement. To be clear, the difference between the Impossible Burger and Beyond Meat. We see Beyond Meat now in the supermarket. I think it's around $5.99 a pound at Stop and Shop. So is there a difference between like the Impossible Burger versus Beyond Meat? You see like the different fast food chains taking on the different products, or are they both just plant-based products?
They're both plant-based, but I forget which one, but one of them uses soy and one of them doesn't. And that's the primary difference. The one that doesn't use soy is using pea protein, which is a kind of exploding plant-based.
Got it. So that's the difference. Another person said, as we have GMO in corn, are the plant sources for producing these substitute meat products totally non-GMO?
It depends. Some countries. Some companies have a commitment to using no GMO like products and no genetic modification in their process. Others don't. So it kind of depends company to company.
Got it. I'll go back to my last question for you, and then we'll end with some audience Q&A. Can you talk a little bit more about the types of research and work New Harvest is involved in supporting this movement? Anything in addition to those students' research that you went over?
Yeah, so those are just 3. We have like more than 15, I think, research fellows right now, and all across the globe too. So one of the more interesting ones, and a sign of maturation in the industry, is we're funding our first kind of non-tissue engineer, Sam Peabody at Texas Tech University. And so he's working on food safety. So figuring out how pathogens might work differently in cell-cultured meat, and getting samples, I think, from different companies, and kind of figuring out this food safety and compliance aspect.
Yeah, super timely.
Yeah. But New Harvest, we also have a conference every year in Boston where kind of the companies and students come together. We had to cancel this year, naturally.
Yeah, I was keeping an eye on that, and I figured it's a bummer.
But that's a big part of what we do. And we also play an important role kind of as a nonprofit in this space. I mean, we're always people always worry that public reception to this will be like public reception to GMOs. And that, I mean, I think that the hostility towards GMOs is less because of the technology and more because Monsanto is a predatory company that took predatory actions. And so people were hostile towards the company actions. And so all of these different cultured meat companies, they want to build public trust, but at the end of the day, they are going to be trying to peddle a product, whereas we are not. And so we're kind of in a unique position because we don't like have kind of lobbying interests. And so education is a big part of what we do.
Definitely. Just a few more audience questions. Let's see. As far as you can tell at this time, will lab-grown meat always require live animals to provide fresh cells for each batch, or will the need for live donors be eliminated?
So theoretically, the need for live donors could be eliminated by something called a cell bank, which you can think of as like a seed bank. Right now, there has never been the need for this kind of bank of initial cells for this wide variety of species that we're trying to culture to eat. And that's another project kind of we're working on in consortium with other groups in the space, is to create this kind of cell bank where you can get the cells from rather than having to go to a farm each time and actually get the cells from the animal.
Got it. What other countries are also doing this technology, and is it more popular in certain countries?
So the country that really jump-started this was the Netherlands, and that's where that first cultured burger happened. The United States, actually, in the very early 2000s, NASA was funding a project to grow goldfish cells to kind of feed people in space. And then they abandoned that. And ever since, we haven't really seen any governmental funding in the United States. But Singapore has committed probably the largest sums of money to this technology. And then there are researchers in Germany and Canada, UK, really everywhere.
Let's spread out. This next question I am super interested in too. Is this considered a way to help solve food shortage for other countries? Like, can this help with like food insecurity? Is this process sort of easier to help feed nations?
It could, but you know, technology doesn't really solve food shortages the ways that we use technology solves food shortages. So it depends on, I think, the IP and patent structure. It depends on how the technology is exported, how different governments interact with the technology. So I think it certainly could help solve food shortage, but it kind of depends on what humans do with it.
Right, like when used in the right way. Let's see. What is the general opinion on resistance to diseases and overall large-scale reduction and variation in the gene pool?
So I think that that's referring to kind of antibiotic resistance and superbugs that develop in factory farms. And yeah, one of the biggest, most promising aspects to this technology, I think, is the elimination of that type of pathogen spread, because yeah, the next pandemic is likely to be from kind of antibiotic resistance bacteria that's developing in factory farms. And so this, it's not to say that you don't use antibiotics at all in making cell cultured meat, but it's kind of at this like initial stage and contained, and then you can just throw away a batch of cells rather than things spreading, and it's in a lot more secure environment.
Right. So besides our usual meat sources, cattle, chicken, pork, they would use this process for producing a fish substitute. Is that what the Netherlands was doing?
The Netherlands, I don't know of anyone in the Netherlands doing a fish substitute, but I do know of lots of people in the United States and Shiak Meats in Singapore. So there's a company called Finless Foods in San Francisco, a company called Blue Nalu in San Diego, Wild Type in, I think, Seattle. And what's interesting about fish is it's a lot easier to make fish meat than it is to make kind of mammalian meat. Because the different species of animal cells behave differently, and we found that fish cells are more amenable to this kind of process. And so in terms, going back to the question of like what the first cell cultured meat product would be, in addition to like hybrid plant-based and cell cultured products, I think a fish product is most likely to come to market first.
Awesome. All right, if anyone has any questions, now's your chance, and here is one. So our sushi could be a Beyond Fish product?
I don't think Beyond Meat is working on any type of fish, plant-based fish at the moment, but I might be wrong.
What's your feeling on like animal rights organizations like PETA? Like, are they on board with this because it spares animals' lives?
Yeah.
Or do they still consider this like animal product?
It's a mixed bag. But if you look at, PETA has had a challenge several years ago where they would give kind of $1 million to the first person that, I forget, maybe made a chicken nugget. And you see, I mean, there's a big support from a big part of the animal rights community. It kind of just depends on people's motivations. But yeah, if you look at this isn't a field that's easy to do or easy to get money. So all of the founders are extremely mission driven, Like I myself got into this from an animal rights perspective back in middle school, actually. So, I mean, I would say that most of the people I interact with in this field are all very mission driven, and that mission is largely, in a lot of the times, animal rights.
All right. So how long have you been involved in this field, and how long has this really been common in our culture?
I've been following this field for 10 years now, but mostly as a kind of voyeur. I've been participating for about 5 years.
Awesome. And is there a difference between culturing chicken type meat versus beef type meat in terms of what is more likely to be produced first, like closer to fish? Like what would be the next, I guess, easiest, I guess, cells to produce?
Yeah, so every species does behave differently. And when I talked about those like building blocks, cells, scaffolds, media, and bioreactor, that media especially has to be optimized for whatever species you're working on. And so kind of whatever cell is easier to culture, it depends on what cell for which it's easiest to optimize growth media, which is one of the most difficult parts. So I can't tell you whether I think chicken or beef would come first, but there is definitely a difference between the two.
Got it. So maybe we'll end with this question. This person, I think people just wanted to know a little bit more about you. So sort of your background and how you got into this. So do you want to just talk about a little bit about that to wrap up?
Sure. So I studied economics and philosophy, so I don't have a science background. And everyone who gets kind of involved in this field, myself included, did so with a lot of effort on their part. Now as it's growing, they're kind of like job listings, but almost everyone I know who got involved did it by just kind of persistently and aggressively emailing someone who was involved and trying to get a job or an internship or volunteer. And so that's how I started. I, in college, emailed New Harvest, emailed New Harvest, and came to New York for a summer. We're a very small organization. We're at our largest now, and we're 6 people. But at the time when I interned, it was just 2.
Awesome. Well, thank you so much for being with us tonight. I hope everyone enjoyed. We had around 20 people, which is a nice size virtual room of people learning. So thank you so much.
Thank you for having me.
All right.